The connection between fire and ice has always seemed like one of opposition, but new research is flipping that idea on its head. It turns out the vast weight of a glacier is not just a block of ice. It is a safety valve on the planet's most explosive systems. As global temperatures rise, we are systematically removing that valve. Scientists are now confirming a stark reality. Less ice can mean more fire. The key evidence comes from the Chilean Andes. A team from the University of Wisconsin-Madison focused on a region once buried by the vast Patagonian ice sheet. By studying the chemical makeup of crystals from 6 different volcanoes, they were able to create a precise timeline of ancient eruptions. The data revealed a stark pattern. During the Ice Age, when the ice was thickest, volcanic activity was suppressed. But as soon as the glaciers began their retreat, the volcanoes roared to life, erupting with far greater frequency and power.
The mechanism at play is surprisingly intuitive. Think of the immense weight of a glacier, which can be thousands of feet thick, as a giant press clamping down on the Earth's crust. This tremendous pressure helps to keep the molten rock, or magma, trapped in underground chambers. It acts like a cork in a champagne bottle. But when the glacier melts, that immense weight is removed. The pressure on the underlying crust and the magma chamber beneath it is suddenly released. Just like when you pop the cork, the dissolved gases within the magma can rapidly expand, driving the molten rock upwards with explosive force. This isn't just a theory. It's a process that has been observed and documented. The new research from Chile confirms that this is not just a localized effect, but can happen on a continental scale. History provides us with a powerful precedent. Iceland, a land famous for both fire and ice, offers a clear case study. Following the end of the last major ice age, around 10,000 to 15,000 years ago, as the island's thick ice cap melted away, its volcanic activity surged dramatically. Studies have shown that eruption rates became 30 to 50 times higher than they are today. This post-glacial boom in volcanic activity demonstrates just how sensitive the Earth's geology can be to changes on its surface. The Patagonian volcanoes in South America tell the same story. During the peak of the Ice Age, between roughly 18,000 and 26,000 years ago, the heavy ice suppressed eruptions, allowing vast reservoirs of magma to build up 10 to 15 kilometers below the surface. When the ice vanished, the pressure was released, and this stored-up energy was unleashed in a series of powerful eruptions that helped form the volcanoes we see today.
Now, as the world's remaining glaciers and ice sheets melt at an accelerating rate due to global warming, scientists are warning that we may be setting the stage for a similar, modern-day resurgence in volcanic activity. The implications are global, with potential hotspots in other heavily glaciated volcanic regions, such as parts of North America, Russia, and New Zealand. However, the greatest concern, the true sleeping giant in this scenario, lies at the very bottom of the world, Antarctica. For a long time, Antarctica was considered a serene continent of ice. But beneath its vast, kilometers-thick ice sheet lies the largest volcanic region on Earth. In the western part of the continent alone, scientists have identified nearly 140 volcanoes, with some peaks as tall as major alpine mountains, all buried under the ice. Currently, only a couple, like Mount Erebus with its persistent lava lake, are known to be active, but many of the others are merely dormant, not extinct. As the West Antarctic ice sheet, which is particularly vulnerable to climate change, continues to thin, the pressure on this massive volcanic system is decreasing.
An eruption under the Antarctic ice would be a profoundly different kind of catastrophe. It wouldn't just be about ash clouds and lava flows. The immense heat from an eruption could melt the ice sheet from the bottom up, creating vast quantities of meltwater. This could lead to a phenomenon known as a Jokelhaup, or a glacial outburst flood, a sudden and catastrophic release of water that can have devastating consequences. Furthermore, this subglacial melting would lubricate the base of the ice sheet, potentially accelerating its slide into the ocean and contributing to a more rapid rise in global sea levels. It's a powerful feedback loop. Melting ice makes eruptions more likely,
and those eruptions then cause even more ice to melt. This creates a complex and worrying picture for the global climate. In the short term, a large volcanic eruption can actually have a cooling effect. The 1991 eruption of Mount Pinatubo in the Philippines, for example, blasted huge amounts of sulfur dioxide into the stratosphere. This gas formed a fine aerosol haze that reflected sunlight back into space, temporarily dropping global temperatures by about half a degree Celsius. However, this effect is fleeting, lasting only a few years.
The long-term consequence of increased global volcanism is far more concerning. Volcanoes are also a source of greenhouse gases, most notably carbon dioxide. While the CO2 from any single contemporary eruption is dwarfed by human emissions, a new era of more frequent and sustained volcanic activity around the world could begin to alter that balance. This leads to the ultimate vicious circle that scientists are now considering. Global warming melts the glaciers that hold volcanoes in check. The unleashed volcanoes erupt more frequently, releasing more greenhouse gases into the atmosphere, and these gases contribute to further warming, which in turn melts more ice.
The findings presented at the Goldschmidt Conference, which gathered over 4,000 scientists to discuss the latest in geochemistry, underscore a crucial point. The Earth's systems are deeply and complexly interconnected. The world of ice, the cryosphere, has a direct and powerful influence on the world of rock and fire, the geosphere. The changes we are causing to the climate are not just raising temperatures and sea levels, they are potentially disturbing ancient geological forces that have been held in check for millennia. The pressure in these deep magmatic systems builds gradually, over centuries, not overnight. But the slow, relentless melting of the planet's ice is progressively lifting the lid, awakening forces that we are only now beginning to fully comprehend.